Okay, Assalamualaikum warahmatullahi wabarakatuh. So, hari ni kita akan masuk equation for progressive wave lah. Okay, so what is the equation? Okay, kalau masih SHM, equation dia is given by x equals to a sin omega t, right? Okay, tapi untuk wave kita guna y lah. Y is equals to a sin omega t plus minus kx. Okay, so dia ada tambahan kx kat situ. Okay, so let's say lah you have y kan. Ni adalah, katalah this is versus time. Okay, katalah this one, y ni adalah, ni ada particle equilibrium. So what happen if we disturb it, dia akan naik atas bawah lah. Okay, so kalau kita ada wave tu, satu wave yang lengkap, so we can find this as period lah. Okay, time taken to complete a wave lah kan. Okay, let's say lah kalau kita tak ada t kat sini, kita ada distance x kan. Okay, so daripada sini omega is equals to 2 pi over t. Okay, so k ni pula formula dia sama dengan 2 pi over lambda. So ni akan dapat daripada graf y against x lah. Tadi tu y against t kan, untuk this one. So this is period. This one y against x. So daripada sini kita boleh tahu x ni lah distance dia daripada source of disturbance kan. Let's say we have a source of disturbance over here. So ni kita panggil dia x component kan, sorry. And then so if we have one complete wave, so kita boleh tahu dia punya panjang wave tu berapa. We call it as lambda. So this one is a lambda. Okay, pada lambda ni boleh masukkan, dapatkan nilai wave number lah. Okay, alright. And then apa lagi kamu kena tahu? Okay, kalau wave tu bergerak ke kiri, to the left, so kita letak positif ya. And then kalau wave tu bergerak ke kanan, kita letak dia negatif. Okay, right. So let's try to do example 1. Okay. Right, a sinusoidal wave travelling in positive x direction has an amplitude of 15 cm. Okay, wavelength sama dengan 40, frekuensi 8 Hz. Okay, find the wave number, period and angular frequency omega and speed of the wave. Okay, so I know that the amplitude is, sorry, so I'll do it here lah. So I know the amplitude is 15 cm kan, and then we have wavelength is equals to 14 cm, and then we have frequency equals to 8 Hz. Okay, and then wave number is k equals to, k is equals to 2 pi over lambda. So masukkan saja 2 pi. Okay, so this one is in meter, right? So you have to change it to meter lah. So this one will be 0.4 meter. Okay, boleh je nak dalam centimeter. So but this answer is in meter, so I'm going to do it in meter. 2 pi over 0.4, so we get 15.71 m negatif 1. Sebab 2 pi ni tak ada unit. Lambda ni unit dia meter kan, so m negatif 1. Okay, and then obviously period adalah t sama dengan 1 over f. So 1 over 8, you akan dapat 0.125 second. Okay, what else? Omega pula sama dengan 2 pi over t. So 2 pi over 0.125. So you will get 50.27 radian s negatif 1. And then last one is apa? Speed of the wave. Ingat balik formula dia apa tadi? This one, isn't it? V equals to F lambda. So guna saja formula tu. V is equals to F lambda, di mana F tu adalah 8. Lambda is 0.4. So your answer would be 3.2 ms negative 1. Okay, right. Let's try to do example 2 pula. Okay, so figure shows a displacement y against x. So kita ada graph y against x. Y against x, kat sinilah y and x bukan y against t tau. Okay, for the progressive wave which propagates to the right with a speed of 15 cm s negative 1. Okay, and then this apa? Determine the wave number and the frequency of the wave. Okay, so we have okay, kita tengok tulis formula untuk wave number apa. Okay, so we have v equals to 15 cm s negative 1 je, right? Okay, and then tengok dia kasih kita graf Y against X kan. So X ni adalah pergerak panjang wave tu berapa banyak lah daripada sini ke sini. So we have multiple waves over here. Okay, so tengok formula wave number apa So K is equals to 2 pi over lambda. Okay, how to find the lambda? Lambda adalah panjang satu wave. So this is the panjang satu. Okay, kalau kat sini adalah 1/4 kan. So ini akan jadi 1/4 tengah-tengah ni. So ni akan tambah 1/4 lah. 1/4 campur 1/4 akan dapat 1/2. Okay, this one akan jadi 1/2 campur 1/4. Which is kamu akan dapat 3/4. And then this one 3/4 campur 1/4, you will get this 1. Okay, so we know that the wavelength is 1 centimeter. Okay, so sekarang ni so 2 pi is actually 1 centimeter is actually 0.01 meter, isn't it? So this one would be 2 pi bagi 0.01. So we get the answer 200 pi. Okay, m negative 1. Okay, and then frequency of the wave. So we know that V is equals to 50 centimeter as negative 1 kan. And then kita tahu pula V equals to F lambda sama dengan 50. Okay, but dia dalam centimeter. So we know that our lambda is before this is so frekuensi nak tahu lambda sebelum ni sama dengan 1 cm sama dengan 50. So our frequency is actually 50 Hz. Okay, and then dia minta apa ni? Dia minta write the expression of displacement as a function of xt for the wave above. Okay, so right, so we know that kalau dia bergerak ke kanan, maka dia akan jadi formula this one, isn't it? So dia akan jadi, okay, for B, Y is equals to A sin omega t minus kx. Okay, sebab dia gerak ke kanan, maka dia negatif kan. And then A kita akan jadi, tengok amplitude kita tadi berapa? Amplitude kita adalah 3 cm ataupun amplitude kita kalau pada body meter 0.03 meter. Okay, so this one would be 0.03 sin our omega. Okay, omega macam nak kira? Omega is equals to 2 pi f, isn't it? So 2 pi 50, so you will get 100 pi radian as negative 1. So this one would be 100 pi t. Dia nak as a function of x and t, so dah buat t. So k pula sama dengan 200 pi x.